we're going to talk about factoring trinomials. So the first thing you've got to remember, trinomials made up of 3 terms. And I've put the standard form there so we can think about what the coefficients are called when we're using a couple different methods today. So we always have something that's squared. So we have the first term here is squared, and the coefficient in front of that we call a. It can be any number, we call it a. The middle term has just the x exponent, and the coefficient in front of it we call b. And then the term that's by itself we call c. So that's the constant term. So we're going to start with factoring trinomials with a leading coefficient of 1, meaning that the a value is 1. So here's our first example, x squared plus 5x plus 6. So we can put a 1 here just to kind of think about it. So we have a 1. So we're going to use a method called the x factor method to help you kind of see what's happening. So when we do the x factor method, we use a big X, and we're going to think about the first term and the last term, and we're going to multiply them together. So 1 times 6 is 6. So in our x factor method, the multiplied a and c term, first and last term, goes in the top. And then our middle term, our b term, goes in the bottom of the x. What we're actually using this for is to help us find factors. So we're looking for numbers or factors that multiply to get me 6, but add to get me 5. So they multiply to get 6 and add to get 5. So let's think about our factors of 6. We got 1 and 6. We have 2 and 3. Those are our 4 factors that 6 has. So we're looking for 2 numbers that multiply to get 6. Well, we know both of those sets do, but they have to add to get 5. Well, the only 2 that'll add will be 2 and 3, to add to get 5. So we're going to put this factor here and this factor here. This is then going to help us break this up into our binomial. So once we do that, remember we're factoring out into a binomial. So we want to get this into 2 binomials here. Well, notice our first term is squared, so we're going to break it up into each piece. And all of these signs here are positive. And when we factored out, we put a 2 and a 3, so we're going to put a 2 and a 3 here, and these are both add. So this is in factored form. And we can double check. X times x gets us back to x squared. X times 3 gets us 3x. 2 times x gets us 2x. And 3x and 2x get us 5x, which is our middle term. And then 3 times 2 got us back to 6. So that's in our factored form. All right, so let's try example B. Again, we're going to use our x method. We're going to look at our coefficient here and here. So our first term and last term. Well, this is a 1 and a 15, so we're putting it at the top. We're putting our middle term at the bottom. We're looking for factors of 15 that multiply to get us 15 and add to get us 8. So we can think about 1 and 15. 2 can't go in there. We can think of 3 and 5. That's the only ones I can think of. So if I think about what multiplies to get 15, well, 1 times 15 does, and so does 3 times 5. So I have to now look at what adds to get me 8. Well, the only 2 that add to get me 8 are 3 and 5. So now I know that I'm going to use these factors in my binomials. This is a squared. So I've set up my 2 binomials, split up my x's. I have a 3 and I have a 5. I know my signs have to both be positive because that's all I have in my original problem. So this is in factored form as 2 binomials. So I have factored the original trinomial as 2 binomials. And if I check back with FOIL, I will get right back to where I started. X times x is x squared. X times 5 is 5x. 3 times x is 3x. That's my middle term. 5x and 3x get me 8x. And 3 times 5 get me 15. So I know I'm correct. All right, I want you to try C and D and see how you do. right, with C, I started here and multiplied my coefficient 1 and my last one, negative 40. So that's giving me a negative 40. I'm looking for things that multiply to get me 40 and add to get me 3. So if I think about, and I wrote my factors here, 1 and 40 won't work. So it doesn't matter really what the signs are. Negative 2 and 20 or negative 20 and 2 won't work because that won't get me the 3. But I have a 5 and an 8. Those will work, and I have to decide which one I want. I need this to be a positive 3. So obviously I'm going to need my bigger number to be positive. So I can use negative 5 and positive 8. Now I'm going to split my binomials, set them up with my parentheses, x and x, and then I'll put my factors right into their spots. So negative 5, positive 8. And I can check with FOIL to make sure it works. So let's do D. 1 and negative 2 gets me negative 2, and I need it to equal a negative 1. So when we think about our factors, 2 and 1, obviously one of them's got to be a negative and one of them's got to be a positive. So my only options are a positive 2 and a negative 1, or a negative 2 and a positive 1. And I need them to add together to get me a negative 1. So I know if I put these together, I'm going to have 1, and it'd be a positive 1, so that won't work. So I know it's got to be a negative 2 and a positive 1. So negative 2 and a positive 1. And then I just set up my two parentheses. My first term, I split an m and an m. I have a negative 2 and a positive 1, and then I can check myself. Make sure it gets back to where I started. All right, let's talk about using the x method, or factoring trinomials, when our leading coefficient is greater than 1. So notice with these, we have a number here in front that's not 1. We're going to use the same method. So we're looking here. We're going to multiply A. This is our A. This is our C. We're multiplying together. We have 2 times a negative 2 gets us a negative 4. And it needs to add to be a negative 3. All right, so we're going to think about factors of negative 4 that will actually work to get us a negative 3. So we think, okay, well, we have a 1 and 4, and that's really the only options. We can play around, or we have a 2 and a 2, but that doesn't get us 4. So these won't work. So 1 and a 4 will work. We've got to think about the signs. I need it to be a negative 3, so I'm going to do a negative 4 and a positive 1. So positive 1 here and a negative 4 here. Now, this one looks a little bit different when we go to finish it, because we can't just put these into two terms here like this, because if we do this here, we still have this 2 to account for. We got to know how to split that up. So we can't just jump straight into two binomials. What we use this x factor for is to help us then factor by grouping. So what these two things did here, giving us these two factors, is took and split up this middle term as a 1x and a negative 4x. So we can write it as a 1x and a negative 4x. And then we'll bring down the a and c as they were. So negative 2 and 2x squared. Then we'll factor by grouping. So we'll group these together, and we'll group these together. Now you learned a little trick about the negatives. When you have a negative, that you can go ahead and change that middle sign. I don't always do that. I just kind of check my signs, but if you're not comfortable checking your signs and worrying about it, you can use the little method that you learned. So now we're going to look and say, okay, is there any greatest common factor that we can take out these two pieces? Well, yes, we can take out an x. So then we can say, okay, well, what will we have left? 2x plus, we just have an x, so it's just 1. Now we got to think about what two common factors do we have here? Well, we have a 2. We can take out, and if I have a negative, if I want to leave this as a positive, I can leave it as a positive, but I got to make sure it actually matches this other piece here. My goal is to get the same thing in here. So I want this piece to be 2x plus 1. Well, what is going to make it get back to there? So if I pull out a positive, this is a 2 times a 2x, that's going to get me to a positive. I need it to be a negative, so I'm going to pull out a negative. A negative times a positive gets me back to a negative. This was a negative first. A negative times a positive gets me back to a negative. Now they're exactly the same. Now you learned a trick where if you see a negative, you go ahead and change this one to a positive so you know it works, and that would have been just fine. So now we have common factors. We pull those together. That's just one. And then our coefficients on the outside get put together. And then it is fully in factored form. Now you can double check yourself and go backwards and make sure that it's correct. All right, let's try another one. So we're going to look at A and C. We're finding factors that multiply to that. So we know we need -9, but add to get us 8. Well, factors of 9 that are going to get close to 8 are going to be 9 and 1. We've got to decide our signs because we know it has to multiply to a -9, so one of these has to be negative, but when I add together it has to be 8. So I know that it's going to be a -1. So a 9 and a -1. Now you can decide how you want to split this middle term up with these two pieces by seeing which one would factor better. Sometimes there's a better choice. So I'm just going to set them up as I wrote them. So 3x squared, I bring my a down, plus my 9x minus 1x. So these factors just split this middle term up, minus 3. Then I'm going to factor by grouping. So I'm going to group together my pieces. And when I see that negative, I can go ahead and change this to a positive if I want to kind of help me know what's going to happen. So now I'm going to pull out my greatest common factor. So 3x will give me x left plus 3. And then think about what I want to do here. I want to make sure that I get back to where I started. So I'm going to pull out, this time, a -1. You think, they have nothing in common. We're going to pull out, and we have to pull out something because we have to have something for this coefficient to go with. So I'm going to pull out a -1. A negative times a positive gets me back to the negative, which is what I need. So I have just the x. And then a negative and a positive gets me back to a negative, which I had before. And that's what I need. A negative and a negative gets me a positive. So I'm going to put back what I had, x plus 3. So now I have two binomials that are exactly alike. So x plus 3, pull them out. And then the coefficients on the outside, 3x minus 1. And then check yourself with FOIL and make sure that it factors back to the original problem. Now, we're going to go to some that aren't necessarily as straightforward, because if we look closely, we can see all these terms, A, B, and C, actually have a greatest common factor that can pull out first. You should get in the habit of always looking for a GCF. So I know that I can pull out a 5 first and factor it down smaller. So I'd end up with x squared minus 2x plus 1. Now I'm going to look at my A, B, and C, and I'm going to find factors. So I have a 1 here. So 1 times 1 gives me that 1. And I need it to equal a -2 when I add them together. Well, factors of 1 are only 1. So we have 1 and 1. And we got to decide what are their signs going to be. Well, a positive and positive is not going to get you a negative. So I have to have a negative and a negative. A negative get me a negative. And when we multiply them, it gets us back to a positive 1. So I know that's a good choice there. Now with this one, I can think about, because it's a leading coefficient of 1, I don't have to factor by grouping. I have a -1 and a -1, so I can go ahead and split this up into two binomials, x, and I have a -1 and a -1. And then I make sure I bring my 5 down. Now, this is perfectly acceptable for an answer, but notice that these two are identical. We can actually write this as 5x minus 1 squared. So this is the nice clean form, but they're both the same. All right, let's go to example B. This is a 2-star. So again, we're going to look and see, do we have a greatest common factor? And yes, I see a greatest common factor that I can pull out. So I think about what can come out. Well, I see a 2 pretty immediately, so I'm going to head and pull out a 2. And nothing else can come out. So 2 can go into 16, 8 times x squared plus 7x minus 15. Now I'm going to use my a and my b, multiply those together. So I know I'm going to get a negative, and 8 times 15 is negative 120. And I need factors of 120 to add up to 7. Now, you can use your calculator to find factors. Remember, you put it in, or you can use Desmos. So I know that one of my numbers is going to have to be negative, and one's going to be positive, most likely, to get back to a 7. So I've used my calculator, and I see I can use a negative 8 and a positive 15. And those will work. So now what I've done is I've found 2 terms, 2 factors that will split up 7, and I'm going to rewrite this in terms of grouping. So 8x squared, and I'm going to put my negative 8 first, negative 8x plus 15x minus 15. My 2's just hanging out over here. He's just watching. We got to deal with him in a minute. So now I'm going to factor by grouping. What can I pull out? An 8x. I end up with x minus 1. I can pull out a 15, and I have x minus 1. So now I put my coefficients together. 8x plus 15 in one binomial, and then these are common factor binomials, x minus 1, and then I cannot forget my 2 and bring him down. So my final answer is this. All right, let's go to a 3-star. So again, we're going to look for greatest common factors, and I don't see anything that I can pull out of 2, 14, and 3. So I have no greatest common factor. So I'm going to look and see, okay, what can I multiply my a and c by? So use my little x. 2 times 3 is 6, but it needs to equal 14. Well, wait a minute. Factors of 6 are only 1 and 6, or 3 and 2. Well, none of those together are going to add to get me 14. So when we see this, we cannot factor it any further. This is called a prime trinomial. It cannot factor. This is called prime. These are not very common. It happens, and you'll see them when you're practicing, but it's not going to happen a lot. So don't assume, oh, I don't know how to factor it, so it's automatically prime. You really need to be careful and make sure that it is. All right, so let's look at some procedures. So you should always get in the habit of looking, when you're looking at trinomials, is there a greatest common factor? If there is, you factor it out first, and if there's not, you're going to move on to the next step. Then you're going to multiply the coefficient for the first and last term, the a times c, and you're going to find factors of that number, and you want those factors to add up to the middle term. Now, you may have to rewrite for grouping if that coefficient was larger than 1. If it wasn't, then it's pretty simple. You're going to factor by grouping and then pull out the common factor of the binomial and then combine the greatest common factor coefficients that you had factored out into the other binomial. You always want to make sure you factored completely and then check with your FOIL or distributive method to go back.